Assalamualaikum and hi everyone. Welcome to Thermodynamic and Material Engineering Laboratory course. I am Dr. Siti Hajar and in this video I will explain how to carry out bending moment experiment. A bending moment is a measure of bending effect that can occur when an external force is applied to a structural element. A moment is a rotational force that occurs when a force is applied perpendicularly to a point at a given distance away from that point. It can be calculated as the perpendicular force multiplied by the distance from that point. To demonstrate the experiment, I will be assisted by our lab assistant, Encik Kamal Azlan. For the experiment, here we have the experimental beam, load, and load hangers. As you can see, the beam is divided into two parts, part A and part B, and is connected by a fixed joint. This beam is 0.9 meter from the left hand side to the right hand side, and every scale line here is 50 millimeter. Spring balance or spring gauge is attached with the beam with level arm of 150 millimeter. This spring gauge will be used to measure the force applied. We have three load hangers here, P1, fixed hanger, P2, and P3, and load of various weight. Here we have 10 Newton, 5 Newton, and 2 Newton weight. Alright, now to perform the experiment, we need to set up the beam as in figure 3 in your laboratory manual, where the load hanger for P1 is 200 millimeter from P2 and P3 is 300 millimeter from P2. Alright, to start, we need to align the two parts of the beam using the adjustment on the spring balance by turning the spring balance knob until the bubble in the balance is at the center. Now, as you can see, the bubble is at the center, and take the initial reading from the spring gauge and jot down in your table 1 for zero load column for all P1, P2, and P3. The reading just now will be the balance reading, and the net force for load is 0 as no load is applied on the load hanger yet. Now, as required in table 1, we apply a 10 Newton weight at P1 and realign the spring balance and record the reading. The new reading is the effect of applying the 10 Newton weight on the beam and will be a balance reading, while the net force is the differences between this reading at 10 Newton with the reading at 0 Newton earlier. Now remove the load at P1 and apply at P2. And again, realign the spring balance to get the reading for 10 Newton load at P2. Okay, so now the reading. So now you can remove the load at P2 and apply at P3. Again, realign the spring balance and take the reading. Now we have completed set of reading for 10 Newton weight. You can repeat the procedure by using 20 Newton weight as required in table 1. Similar procedure is also conducted to get data for table 2, which is data for bending moment at C for the load configuration in part 2. Now, we move on to data collection for table 3, which is data for bending moment at C for load configuration in part 2 with different positions and load. For this experiment, P1 is at the same location as before, while P3 is adjusted to be 200 mm from P2. Now, as in table 3, apply 5 Newton load at P1 and 12 Newton load at P3. Again, realign the spring balance and record the reading. Repeat the same procedure for the next load as in the table 3. The data or reading that you get can be used to calculate the experimental bending moment, and later you can compare it with theoretical value. And remember, to calculate the bending moment, you need to multiply the reading with 150 mm, which is the distance between the centroid of the beam and the spring balance. In order to improve the accuracy for the experiment, you have to make sure the position of the eye should be perpendicular to the spring balance, and always make sure the load hangers are at the right position each time applying the load. That's basically how to get the data point for this experiment. The concept of bending moment is very important in structural engineering, as it can be used to calculate where and how much maximum force can be applied for a particular beam or structure. Thank you for your attention, and hopefully this will be helpful to you to complete your laboratory assignment.